So let's take a look at the current in a simple circuit. Let's first have a battery. This is a battery, and of course this is the plus end and this is the minus end of the battery. These two parts, these two ends, are called terminals. And let's join the battery with copper wire to a lamp. Or a bulb, as we would say. This is a bulb, and inside is the filament. And then we join that here, and we're going to have a switch in the circuit here. That's the switch. And as we know, an electric current means a flow of electrons. So which way would the electrons flow? Of course, they're attracted to the positive, so the electrons like that would flow towards the positive terminal of the battery. This is a copper wire. And of course, to make them flow, we would have to close the switch. Now, as we know, electric current equals an electron flow. And this is measured in amperes, shown with a capital A. Often when we talk about it, we just say amps. And 1 amp is defined as the flow of 6 times 10 to the 18 electrons. That's actually 6 quintillion. Because that's quite a lot, we often use milliamperes. So 1000 milliamperes equals 1 amp. Typical examples might be, for example, a torch, a normal torch. We might have a current flow of 0.2 amperes, which of course we could write as 200 milliamperes. A car headlight would be typically about 4 amperes, and an electric kettle would have something like 10 amperes. Now, as you see here and here, I've actually drawn the battery and the bulb, but there are shortcuts to drawing these circuits. So let's take a look at the shortcuts, and we call these circuit symbols. Typical symbols for a battery, which a battery actually means a number of cells. This is one cell, and by convention that will be the positive terminal and that will be the negative terminal. Connecting wire is easy. It's the wire. The switch that we saw is shown like that when it's open. A bulb will be like that. So that's a bulb. That's a switch. And one other thing, of course, we want to measure the current, and for that we use an ammeter. Measures the flow of current, the flow of electrons. And if we now draw a circuit using these symbols, we have a battery, we have the connecting wire with the switch through to a bulb and back to the battery. And of course let's close this switch. We would now have a flow of electrons. What's interesting, of course, if we here and here, if we put in an ammeter in both positions, so an ammeter here and an ammeter here, and let's say this ammeter reads 2 amperes, what would this other ammeter be reading? This one here. Well, it actually would be reading the same, 2 amperes. So the actual flow of electrons going around the circuit in this direction is the same at any point around the circuit. So we can say current is the same all round the circuit. We have a measurement of how many electrons are moving per second. So we're looking at time now, and if we have 1 ampere per second, that will be 6 quintillion, that's 6 times 10 to the 18 electrons flowing per second. We call that a coulomb. So we could say a coulomb, C, put that C in, equals the amps per second. So that would be the calculation for coulombs.